we're asked to sketch this polar curve. Now, you've got two options really. You could go away and buy yourself a graphical calculator and get it to do it for you. Or, and I would advise this, you spend a bit of time understanding these curves and being able to sketch them. And then, okay, maybe in the exam, you then still get that graphical calculator if you want. So we're going to look at a related curve to begin with. Y equals A times 1 plus cos theta. And this has a special name. It's called a cardioid. Ours is not quite in that form, so it'll be a related curve. And cardiac is related to the heart. This ends up being a heart-shaped curve. This is one way to remember it. So when theta is 0, cos theta is 1, we're going to get 2a. Remember, we're doing it in polar form, so this is where theta is 0 along this line. We call it the initial line. And then if we look at the cos curve, we can see that it actually decreases and then increases like this. So it's going down, and actually when theta is pi over 2, up here we get cos theta is 0, so we're just going to get a. And then when theta is pi, we get minus 1, and it goes here, and then we basically get a reflection because the cos curve has this line of symmetry here. And what happens is that I mean, this is quite subtle now, and you wouldn't necessarily know this the first time. You might think to just, I guess that bit makes sense. You might draw it like that, but actually the peak is up here, and it's on its way down. But you do get it coming in like this, and you get symmetrical things. So a little bit like a heart, as you can see. So let's take a look at ours. Ours is not quite in that form, but it turns out in this question it ends up having the same sort of shape. So let's do a table of values because we're meant to be labeling the pole, the initial line, the value of r at the point where the curve intersects the initial line. So I think we should just get a few points down, and I will do it here. Okay, so this is going to be the initial line. I'm going to label the origin. That ends up being a pole. So then I've got theta and r, and we'll put in, just like before, like we talked about, 0, pi over 2, pi, 3 pi over 2, and that's it, because 2 pi will be the same. So now when I put in 0, this is not quite in this right form. Like it would be actually root 5, 1 plus cos theta, but then I'm adding on 3 minus root 5. So we're going to kind of have this sort of shape, but this actually has quite a big impact. So it's not like I can talk about translations or anything. But I'm just trying to show you that it is strongly related to it. So when r is 0, we're going to get 3 plus root 5, which is about 5. I'll just put it here. We don't really need to be like really accurate, but I'm going to label that one 3 plus root 5. That is what the value of r at the point where the curve intersects the initial line. But there's going to be another one, different point. And then pi over 2, that's when we're going to get 0, and we're going to get 3. Then at pi, we get minus 1, so I'm going to get 3 minus root 5. Now, this is still positive because root 5, although it's bigger than 2, it's less than 3. So I'll put it in here. And then 3 pi over 2, we again get 0, so we get 3 again. There's going to be symmetry going on. And what is going to happen is that it's going to come up, it's going to hit a peak, then come down. It's going to go out, so, but we're still going to get it going back in. This is referred to as a dimple. It's going to bend around and look like that. So that is our sketch. Now, just to clarify one thing, although I think it's quite useful to draw the x and the y axes, the initial line is the line coming from 0. It's just that bit there. So I only needed to quote the 3 plus root 5, not the 3 minus root 5, although I think it helps, so I'm going to stick with it. And I'm going to add the 3 here and here as well. And just finally, I'm just going to talk a little bit, like this is not, you have to delve into it a little bit more to understand why this is the case. But so the kind of general curve we've written here is A times P plus q cos theta. And it's when p is equal to q that you would get this cardioid curve at the bottom. Now, one thing, and this requires some looking into tangents and everything, but one thing to know is that if p is greater or equal to 2q, then actually you won't get the dimple. Whilst if p if q is less than or equal to p, which is less than 2q, then you will. So that's just something to look out for in these kind of questions. Because 3 is bigger than root 5, then we're in this zone here, but it is less than twice it. I'm not going to go into what happens if p is less than q or if p is greater than 2q. I'm just going to talk about these two situations here, but it's something to be aware of. This is our final answer for the sketch. Now we're told that the tangent to C at the point A, where theta's between 0 and pi over 2, so that's going to be in this first quadrant, is parallel to the initial line. So from our sketch, we can see that it's going to be slightly above. It's going to be something like this. I'll ask you calculus to show that at A, cos theta is 1 over root 5. So this here would be our line R, and then this angle would be theta. So we're going to have that dy by dx, because it's parallel to the initial line, dy by dx is going to equal 0 at A. And we can use the chain rule. It must be that dy by d theta by dx is equal to 0. This is the same as dy by d theta over dx by d theta. And the only way this can be true is if dy by d theta is 0. So actually, I don't even need to work out dx by d theta. You can if you want. Right, so we need to get y in terms of theta. But I've already drawn a little line, so I can draw a triangle now, and I can see that this would be x and this would be y. And that is the opposite of the triangle. It's going to be r sine theta. Y equals r sine theta. But remember, we know that r is equal to 3 plus root 5 cos theta. So I can multiply that by sine theta, and I'm going to get 3 sine theta plus root 5 sine theta cos theta. Okay, this is where we bring in our double angle formulae, because I want to differentiate this with respect to theta. It's going to be a little bit easier. I mean, you could use the product rule, but remember, sine 2a is 2 sine a cos a. So I can write it as 3 sine theta plus root 5 over 2 sine 2 theta. So therefore, dy by d theta is going to be 3 cos theta plus root 5 cos 2 theta. And that is going to equal 0. So just got to solve that now. Okay, I'm going to have to use double angle formulae again. So maybe, I don't know, would it have been better to use, I don't think it would, no, it wouldn't have been better to use product rule, would it? I don't know. Anyway, let's get it all in terms of cos theta. So cos 2 theta is actually 2 cos squared theta minus 1. We get that from the more general formula. Cos 2 theta is identical to cos squared theta minus sine squared theta, and we can replace sine squared by 1 minus cos squared theta, and you end up doing minus minus cos squared theta to give you the 2 cos squared theta, and then of course we are still minusing 1. So that means it's going to be 2 root 5 cos squared theta plus 3 cos theta minus 1 equal to 0. We've got a quadratic. And we can just put that in our calculator, go for it. So cos theta is then going to equal 1 over root 5 or minus root 5 over 2. Now this is actually less than 1, so we're going to reject. Okay, that is a non-physical solution. And that's what we needed. So we just needed to show that cos theta was 1 over root 5, and that's what I've done. Just looking at it again, if we had differentiated this using the product rule, you would have got a sine squared term and a cos squared term, and then you would have replaced the sine squared by 1 minus cos squared and gone from there. So I don't know which one's better. I quite like the way I did it. I'm not going to go for it any other way. Finally, hence determine the value of r. It's a. Okay, this is going to be pretty quick. So we know that r is equal to 3 plus root 5 cos theta. So at a, r is going to be 3 plus root 5 times 1 over root 5, which is going to give an answer of 4. You might be tempted, like when you're going up here, to make that one the maximum, but this actually, shows in a bit more detail why actually it hits, well, the fact that it does hit the maximum at a higher point, just to justify it. But just learn this cardioid kind of curve and the different circumstances if you can, and look into it where like look into these conditions and have a look at proving them. I'm not going to do that here, but it's investigating the tangents that are then perpendicular to the initial line or parallel to the y-axis. Well done.